Hello. So this is our face mask detection through CNN model. So first we have imported our models like the models that our libraries are NumPy, Panda, Matplotlib for plotting the our graphs, and for our CNN model we have used Keras and the TensorFlow. Then we have that sklearn matrix for our putting our the confusion matrix for the validation and error, and last we have that our computer that CV to visualize the image, and Seaborn again for plotting the datas. So we have mounted our Google Drive here. Then we have uploaded our data set, and we have some annotation about regarding our images. So first we'll go through the annotation of those images. We have total 853 images here, and we will crop those images from those 853 images, because in between those images we have some more faces, so we'll crop those faces from those images. So this is our XML file. From XML file we get this we made this data frame. So this is our data frame head. So here we have the information for that within these images for the position of the face marks, with marks or without marks, or the that incorrect marks. So we have three levels here. So see here where this are for the first images what we have. So that for that for all of the images we have some that information regarding the faces we have on those images of with marks, without marks, or incorrect marks. So these are the value count the that we have around 3285 images with mask, and without marks is 717. Then marks were incorrect are 123. So here is the representation. So we have mostly with marks faces on those 853 images. So now we'll try to crop those. So we have divided some our directory into train, test, and validation. So here we are cropping those codes for cropping the images from our 853 images, and for keeping the test, train, and validation directories. So we have crop images, then we have flatted the crop images, then we have labeled those images to our uh, directory that with marks were incorrect and without marks. So here's the length as we counted 3008 3286 images with marks, 719 without marks, and 123 as marks are incorrect, and total number is 4128 images of our faces. So we have that split our data set, those 4128 images for train, test, and validation. Now that here we have assigning the all images to our that directories. So we'll get a directory like this: test, train, and validation. Here for testing we have some images that with those three levels. For train we have this, and for validation. Moving next, we are defining our model. So as I mentioned, I have used our Keras for calling our model. So let's see the parameters of our model. We are giving the input as 35, 35, 35 plus 35, and that our filter is 16. So initially we are getting parameter around 443. Then we use max pooling. So then after the max pooling layer, we will get 17 cross 17 and 16. Then again we are calling the doing the convolutional. Then again we are going for max pooling, and later we are getting around 8 cross 8 32. And after again going for our convolutional neural network, we are getting around 18,496 parameters. Then again we are doing the max pooling with 4 cross 4 and 64. So finally we are that we drop out uh, the parameters, then we flattened it. After then we are passing those parameters through our hidden layer, the dense layer here, around 5,000 5 lakh 12,500 parameters. Finally that our trainable parameters what we got here is that 5,3700 587 parameters. So we define the base size and epochs. We are taking 50 epochs for training our data set, and that validation in. Then we are generating those image data. That here, as I mentioned, the directory that content train, content validation, content test. Here our the data set. So we found around 3,263 images for three classes, like for testing, 583 images for that sorry training, and 580 images for testing, and for validation 247. So here is we are going for our model. So we as we have to do the count the accuracy. So we choose that our matrix is accuracy, recall, precision, and AUC curve. So we use also ADAM optimizer. So we define some parameters for our model to testing the accuracy. So finally we fit our model with 50 epochs. So here the some that loss and accuracy, all the things. So for the first epoch we got around accuracy 83%, recall 82%, precision 84%, and the AUC curve we got that below around 91%, validation loss is 39. So here the parameters. So if you move down for the other epochs, at the last for 51 epochs we are getting around accuracy 94. So it's increasing as we can see, and the AOC is covering the whole area around 99%, and the validation loss is more or less 18%, and validation is 94%. So here the parameters that best the 31 that epoch we got the best result around 93% accuracy, recall 91, and precision 94. Then if we move back to our that now we are predicting our model. So this that with the data set we are providing for the testing. So we got some that results for probability for that for all three levels, for with marks, without marks, and marks are incorrect. So finally here we are saving our model head to for our future purposes that we can implement in any of the web application or applications. So and now we are plotting our validation and that loss and validation loss. Here through our graph we can see that is that following the same path, though we are doing our implement our model with the images, so it's fluctuating, but we can see that most of the time our validation loss is below to our loss function, that curve. Also the accuracy also below to our validation validation accuracy is below to our accuracy curve. So here we can show you some predictions. Is we are taking random images. So it's predict the true level was that, and the predicted level. So we are getting this level that it's with marks. If I run this particle block again, it will change again. We will get any random image. Maybe it's with marks. So see, we are getting with marks level here with our model. Again I will go for another image. Again this also it's declaring that it with marks. Let's see another random image from our well, data set. Yeah, here it's that showing that it has, maybe it has beard, so it's okay, it has with marks in true level, but it's can't detect that it is detecting without marks again. Yes. So this is the prediction of our model. If you now we are showing the that confusion matrix, like the true prediction and that all the things. Here we are the parameters we got, then the actual one uh, by the predicted one. So here is a count for those parameters around like that one for with were incorrect with marks to 2205 and without marks for 41. And here we can upload our own images to test our model. So let me show you. I'll go for this image. It's with mask. Let's see that our JPG name is mask. So I'll put the name here, mask, or I can also access it from here. See, here we have uploaded our images. The directory is this one. So I will run this. So let's see the prediction. So here the we are getting the array for the one means that with mask. So our model is predicting the correct one. Let me show you the image what we are. So as we passed our images as 35 cross 30, so we are getting some images that images in that manner. So it's detecting that with mask. And that's all. Thank you.